finally, we get to add and subtract fractions that have variables in it. I know you've been waiting for this. Before we get to that, I just want to rewind a little bit and think back to when we were simplifying algebraic expressions. Things like 2x plus x. And we noticed that those two terms, 2x and x, were called like terms because they had the exact same variable. We could combine them. We could add them because they had the same variable. And when we do that, we add the coefficients. And what's the coefficient of x? 1. So 2x plus 1x is 3x. So that's an important fact that we're going to have to use as we go through these problems. So I'm just going to take those same terms and put them in fractions. So let's say we have 2x over 5 plus x over 5. I know that we sometimes fractions and working with them can be a little difficult, but we just did some that didn't have variables in them. Okay, and we got through those. We've also talked about how to combine like terms. We're just merging those two ideas here. The fractions are still going to behave like fractions. So when we add fractions, the denominators have to be the same. And they are, 5 and 5. So when we add them, it's just counting the number of fifths. How many do we have? Well, we have 2 times x plus 1 times x. 2x plus 1x is 3x. We just add the numerators. 3x over 5. Now, what if the denominators are not the same? What if we have x over 3 plus 2x over 9? In the last video, we talked about getting common denominators. And the way I told you to think about it was building the common denominator by thinking of the prime factorizations. 9 is composed of 3 times 3. So if we're building a common denominator, you might just look at it and already know, but I still want to treat it like this. This one has a 3 already, and this one has a 3. But this one has an extra 3. So this one needs an extra 3. So we'll do 3 times this, and then 3 times that, right? Multiply the top and the bottom by the same thing. Now, after that, we have 3x over 9 from here, plus 2x over 9. I didn't have to change this denominator at all. That could just stay as it is. Now we can add 2x plus 3x is 5x over 9. Right? That's how many ninths we have. 5x over 9. So, what about x over 4 minus 3 over 4? Pause the video, try this one. So what you'll notice is that I gave them to you with common denominators. Okay, they came already prepared, but it's subtraction. Oh, one has a variable, but the other doesn't. So what I want you to do is combine them into one fraction. Combine them into one fraction. So when we do that, we know the denominator has to be the same, so it's going to be fourths. But what's the numerator going to be? We have to do this stuff, right? Well, how do we subtract a variable minus a number? You can't. You can't unless you know what the variable is. So they're not like terms, so we just have to write it. This is how we would answer the question if we knew what x was. This is all you can do to simplify that expression. Combining the two fractions together in subtraction doesn't always mean that you can combine the two terms together on top. So we leave it as x minus 3 over 4. Here's another one. 7 over 2x minus 5 over 2x. Pause the video, stare at it, think about it, try something. In this case, what you might notice is that there are variables in the denominators now. There are no variables in the numerators, but they are down below. But they're the same. they both have a 2x, which means I don't have to change them at all. Just like the other problems, that's going to be the new denominator, 2 times whatever number x is. And what do we have to do? We have to do the top. Now, unlike the previous problem, where they were different terms, they were not like terms, 7 and 5 are just numbers. 7 minus 5 is 2. So I can write that as 2. However, this one can be simplified. Pause it and see if you can simplify it properly if you haven't done so yet. So I think about removing common factors. I see a 2 and I see a 2. This 2 is times x. This 2 is times what? 1. So there's a 1 there, even if we don't see it. When we cancel, canceling the 2's leaves us with 1 over x. Big mistake on that type of problem is canceling the 2's and then just putting the answer as x. No, the x is in the denominator. We can't just pull it out of the denominator. It's got to stay in that denominator. Okay, let's try another one. 3, they're going to get more fun. 3 over 2b plus 1 over 4b. I'm using all sorts of different variables, letters. It doesn't matter what letter. It just means a number that we don't know what it is. So, pause and try it. Well, okay, this is one I might want to do the factorization thing on. 2 and b just means 2 times b. I can't really do much. But 4 means 2 times 2 times b. So just like before, we look to see what they have in common. They both have 2's and they both have b's. But this second fraction has an extra 2 in it, right? It has an extra factor of 2, which means I need to include that factor over in this first fraction. So I'm going to multiply the top by 2 and the bottom by 2. And when I do that and change it, I'm going to bring it down here. 2 times 3 is 6. 2 times 2 times b is 4b. I don't have to change this one at all. It's already 4b. But I want you to start to see the denominators, not just as a single thing, but as the components, the ingredients that make them up. It's going to be much easier for you to figure these things out moving forward. Then we combine them. They have the same denominator, 4b. 6 plus 1 is 7. 7 over 4b. And lastly, one more. Really fun one here. So, 2 over m minus 6 over 7. Pause, try it. So I'm looking at these denominators. It's subtraction, it's fractions. I've only got one variable. It's over here. I know I need to get a common denominator. So what I notice is, if I think about it the same way I thought about the last problem, I can't factor m. M is just m. And I can't factor 7. It's a prime number. So I think about it like this. This one has an m, so this one needs an m. So I'm just going to do times m. And I have to do it on top and bottom. Same number on top and bottom. This one has a 7. This one needs a 7. So I'm going to put a 7 over here. 7 times m and 7 times 2. In an individual fraction, as long as we multiply the top and the bottom by the same number, it stays the same fraction, just looks different. Let's clean it up. 7 times 2 is 14 over 7m minus 6 times m is 6m over 7m. Went through each part of the fraction and just simplified it. I cleaned it up. Now we can do our actual subtraction. We're going to combine them into one fraction. That's what our goal is here. They both have the same denominator. It's 7m. But look at the numerators. Look what we have here. We have 14 minus 6m. 14 minus 6m. 14 and 6m are not like terms. 14 is a constant, right? It's just a number. And we're subtracting 6m, which has a variable. So we can't actually combine them at all. Now, that's as far as we can go. And I know what you might be thinking. I know what some of you are thinking, because I've you've sort of been trained to try to cancel and simplify things, and you're thinking, can I cancel these m's, or can I cancel the 14 and the 7 with the 7? No, you absolutely cannot. And it's because canceling or simplifying a fraction means, so to simplify means remove or cancel common factors. And the key word there is factors. Factors are things that are multiplied. When we have all multiplication across the top and all multiplication across the bottom, then we can cancel the common factors. But up here, there's a minus sign. It is not all multiplication across the top. There's subtraction up there. You cannot cancel part of an addition or subtraction expression. Okay? We'll talk about that later, actually, in Math 40, canceling more complex polynomials and things. But this, because that m isn't in both of these things, you can't cancel it. Okay? So for now, simplifying fraction is removing common factors, which means it has to be only multiplication all the way across the top and the bottom.